Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our third lesson on distance time graphs. Just before we get going on this particular lesson, let's talk about prior learning we need to be really good at. You need to remember how to work out the gradient of a straight line graph. You take the difference in y's and you divide it by the difference in x's. We're going to need that. And also, you need to remember what average speed is and how to calculate it. Average speed is distance travelled divided by time to travel that distance, or we shorten it to speed is distance divided by time. And the units are often meters per second, kilometers per hour, or miles per hour, etc. And what we did previously on distance time graphs is we talked about how they look, we've read them, we've drawn them, and we did say that when there's a straight line on these, it means we've got a constant speed in that period of time. So let's develop this idea further and link the gradient of a distance time graph to speed. So imagine I had the following scenario. Emma, Jordan and Sam all walk 5 miles from their house, each walk at their own constant pace. Emma walked the 5 miles in 1 hour, Jordan took 2.5 hours, and Sam took 4 hours. Before we draw anything, you can easily say who's fastest, who's slowest. Emma's fastest, she did the whole 5 miles in just 1 hour. Sam's slowest, Sam took 4 hours to do the 5 miles. But if we were to draw a distance time graph, these are usually quite useful. So for Emma, we can draw Emma in there. She goes 5 miles in 1 hour. Jordan took 2.5 hours to do the 5 miles, and Sam took 4 hours to do the 5 miles. Now, they all did the same distance, 5 miles, but they did it in different times, and this means that their gradients are different. The gradients of these lines are different. This one has the steepest gradient, Emma, she's going fastest. This one has the shallowest gradient, it's Sam's, and she's going slowest. So the gradient does tell us about the speed, how quickly they're moving. And actually the gradient is the speed. I'll show you why. Remember the gradient, one of the meanings of the gradient is how far you go up for every unit you go across one. So for Emma, if I go across one whole unit here, 1 hour, I go up 5 miles. So for Emma, the gradient is 5. What about for Jordan? Well, as we go across 1 for Jordan, we go up 2. So for Jordan, the gradient of his line is actually 2. And lastly, for Sam, well, as I go across 1 for Sam, this looks like, well, it looks like halfway between 1 and 1.5, and halfway between 1 and 1.5 would be 1.25. So it looks like that has a gradient of 1.25. Now, also what I'm going to say is, if I separately calculated the average speed, you would see they're the same. In this particular case here, because we know speed is distance over time, the distance is 5 divided by the time here for Emma is 1, and that would give us 5. What about for Jordan? Well, Jordan travels, his speed would be given by, he travels 5 miles in 2.5 hours, so that gives us a speed of 2. And lastly, for Sam, we know that the speed for Sam, well, Sam goes 5 miles divided by 4 hours, and that gives me 1.25. So hopefully you can see here that the gradient tells you the speed. And that is the key thing we're going to do here. When we want to learn or find out the speed when we have a distance time graph, if we work out the gradient, it will give us the speed. So just a diagram to show you this here. When we have a horizontal line, we've got no speed. The object's not moving. When we've got a positive gradient here, well, we've got a positive velocity. And when we've got a negative gradient, we've got actually a negative velocity. Now, I'm going to talk about velocity in an example later, but velocity is a speed in a direction. So when it's a positive velocity, it means it's all moving in the same direction. Here, we've got a speed here, but we're just moving in the opposite direction. But we'll talk about that later. The key thing here is the gradient of a distance time graph is the speed. So let's get on and use this idea. Here's our first question. Pause and have a go. So we've got two cyclists, Amanda and Brian. They cycle 80 kilometers from their homes. Calculate the average speeds for Amanda and Brian. So Amanda here, her average speed, well, we can work out the gradient of her line. She goes 80 kilometers in 5 hours. Okay, so she actually starts over here at 0, 0. She ends up 5 hours later at 80 kilometers, and we can work out the gradient there to get her average speed. So I'm going to just call her average speed is the gradient here. So I'm going to do 80 take away 0, difference in y's, divided by 5 take away 0, and when you do that you get yourself 16, and the unit would be kilometers per hour. And for Brian, well, Brian also starts at 0, 0, and he ends up at 1080. So his gradient, or his average speed, let's work out the gradient, is 80 take away 0 divided by 10 take away 0, which is going to give me 80 over 10, which is 8 kilometers per hour. Just by way of interest, we could have worked this out another way. If we go, because they're straight lines the whole way, if we go across 1 hour, here we've gone up 8 kilometers. So for Brian, it's 8 kilometers per hour. If we go across 1 hour here, we have gone up, it looks like 16 kilometers. So that's why it's 16 kilometers an hour. You won't always be able to do that because the lines won't always be a continuous straight line. There will be stops and changes in speed, etc. Okay, next question. Pause and have a go. So we've got two cyclists, Chloe and Mo, go for a cycle, as in the distance time graph. Calculate the average speeds for both of them. So the average speeds over the entire journey here. So let's do Chloe first. Chloe should be a bit easier. Chloe starts at 0, 0. She ends up over here at 10 in 10 hours at 60 miles. So let's write her coordinates down here. We've got 0, 0 and 10, 60. And we know that the gradient of this line is going to tell us her average speed. So her average speed, well, it's difference in y's, so 60 take away 0, divided by difference in x's, 10 take away 0, and that's going to give us 6, and the unit there is miles and hours, so we've got miles per hour in this case. Let's do Mo now. Now Mo's a bit more complicated, his speed changes, but we start off at 0, 0, and all we care is where we end up. We end up here at 1050. So we want the average speed between there and there. In effect, we want the gradient of this line here, because he goes faster, then he stops, then he goes slower. But we want the average speed. So we want the gradient between here and here. And to do that, we're going to work out average speed is difference in y's. So we're going to do 50 take away the 0 divided by 10 take away the 0, and that's going to give us 5 miles per hour, and we're done. Okay, next question. Pause and have a go. So we've got two cars here, an Audi and we've got a Tesla, and we're told that they both travel 180-mile journey. Which car is fastest and by how much? State your answers in kilometers per hour. Now by the looks of it, it looks like the Audi's faster. It's got a much steeper line. The Tesla's got a shallower line. But be very careful here because the units are different. This x-axis only goes up to 10 hours and this one only in fact goes up to 4 hours. So it's not obvious what's going on, and their y-axis have different scales on them as well. So let's just one by one work out what we think the average speed is. So let's do an Audi and let's work out its average speed. It starts at 0, 0 and it ends up at 5180. So it starts at 0, 0 and it ends up in 5 hours at 180 miles away. So the average speed is going to be the gradient here, And so we can do difference in y is 180 take away 0 divided by the difference in x's, which is 5 take away 0, and we've got ourselves 180 divided by 5, which is 36. We've got miles, we've got hours here, so it's going to be in miles per hour. Next one, the Tesla. Well, the Tesla starts at 0, 0 and ends over here at 4, 180. So its average speed, again, is the gradient, which is difference in y is 180 take away 0, over the difference in x is 4 take away 0, and when we do that, we get ourselves 45 miles per hour. Now, that wasn't the question. The question was which car is faster and by how much. So the Tesla is faster by 45 take away 36, which is 9 miles per hour. And we're done. Next question. Pause the video and have a go. So James went for a cycle, as shown in the distance time graph below. He started off so fast he had to stop and recover for 2 hours. So he goes off super fast, and then you can see here he stops for 2 hours. He then continued cycling until he reached his destination 70 miles away. So he finishes at 70 miles up here. How much faster in miles per hour was James in the first 2 hours than the last? So the first 2 hours is him travelling along there, and the last 4 hours is him travelling there. We need to work out the speed for each section. So let's do for the first 2 hours. Let's write our coordinates. He starts at 0, 0. He ends off here at, let's just write 0, 0 is where he starts. And he ends at 2 hours. And we've got to be, this is at 34. So 34 miles there. So his speed in this particular case will be the gradient, which is difference in y's, 34 take away 0, over difference in x's, 2 take away 0, which will give us 17 miles per hour. His last 4 hours, let's do in a different color pen. Well, he starts here at 4:34 and he finishes up here at 8:70. So the speed is going to be the difference in y's, which is 70 take away 34, divided by the difference in x's, 8 take away 4. That's going to give us 36 over 4, which is going to give us 9 miles per hour. Now, that wasn't the question. The question said, how much faster was he? So James was 17 take away 9, which is 8 miles per hour faster in the first 2 hours. And we're done. Next question, pause and have a go. So here we've got a distance time graph showing a car travelling away from London and then returning. Calculate the speed while leaving London and then calculate the speed when returning. So when leaving London, the distance from London is increasing, so it must be this section here. It seems like the car stops for a bit and then it returns as the distance from London decreases. So we're going to calculate the gradient when it's leaving London and the gradient when it's returning from London to get those speeds. So where do we start here? We start at 0, 0 and we end here at 275. So we're going to work out the speed by getting the gradient, which is difference in y's, 75 take away 0, divided by difference in x's, 2 take away 0, and that will give us 37.5, and we've got miles per hour as our unit. Let's do the speed on the return in a different colour. We start here at 575, and we end here at 90. So the speed here is difference in y's. Let's maybe start with big Y there. So what we're going to do is we're going to do 75 take away 0 divided by 5 take away 9. And That gives us 75 over -4, and when we type that into our calculator, we actually get ourselves a negative answer, negative 18.75 miles per hour. Now, actually, this is the velocity. The velocity can have a sign. Negative means that it's going towards London. So positive means it's going away from London. Negative means it's going towards London. When they ask you the speed, you're not supposed to worry about it being positive or negative. Just write 18.75. So here we're going to write 18.75 miles per hour, and we're done. And that's it for this particular video. Thanks for watching.